Hello students, I hope everybody is doing good. This is the Python development workshop day 2. Yesterday we looked upon to the what is Python or how in Python we can create variables, what are the rules for creating the variables. Also we looked upon the some built-in functions in Python. We also looked upon the conditional statements in Python such as if, elif and else. Then we looked upon to the another multiple storing data type that was list. In today's session, we'll continue with the list only. We'll have some more attention towards it and we'll try to learn more functions about the list. Recovering the list, let's start. I present my screen to all of you. Okay. Yesterday we started with the list. So as we all know that list is a data type in Python. There are numerous data types in Python such as int, float, and boolean. Character, for character we have string, but they store only single data. To store multiple values we require in Python we have list, tuple, sets, dictionaries, etc. Coming on to the list as I told you is a mutable data type. Mutable data type means it can be modified and manipulated after once it's even created. Also, I told you that list is orderable, modifiable, and can contain duplicate values. This is not true for every case, like for tuples, for sets, for dictionaries. You cannot have duplicate values, or there are some other conditions with it. But for the list, it is orderable and it even contain the duplicate values. I told you in Python we have zero based indexing. That means the first element of a list is going to we have index 0. The last element is going to have an index -1, or it can have n minus 1 index, where the n is the total number of elements present in the list. You can create a list using the list constructor. Then I told you some of the things about the list functions. I told you about the length function. I told you about the append function and how to create a list. The elements inside the list are always uh, there inside the bar braces. This was all about. Now today we'll have some overview over the list functions. These are some of the list functions that I've covered in my slides, whereas I will have some more practical review over it on the Colab as well. So let's get started. Okay. As you all know that I told you yesterday how to create a list inside a Python. Suppose if you have a list lst with the name, with the values, let's say 10 comma 20 comma 30 comma 40 comma 50. So these, the total number of elements present inside the list are 5, as you can count also. Yesterday we learned about how you can iterate or get into a particular element inside a list. It can be either using a for loop, or it can even be with the indexing. So okay, now we'll see how you can update. We'll go to the slide wala portion baad mein. We'll also take a review over it, but let's now have a practical application. Since I've already told you how you can get an index, for the index we simply write the name of the list is lst here dot. Okay, for the list name is lst. Suppose if you want to have a very first element, okay, so very first element is always at the index 0. Let's print this. This is probably going to give you the very first element of your list, that is 10. Okay, till the time it's giving you the output, let's see some of the other things. Similarly, if you want to have a second element, we'll write a list with the index 1. Okay. let's come here. We'll comment. For the comment I told you, we'll use the hashtag for the single line comment. Okay, I've already told you. Since Python follows the zero based indexing, you can start your first element with the 0, and then later on you can go ahead as per the number of elements present inside your list. This is the zero based indexing, or you can say this is the forward indexing. When you're coming on to the backward indexing, 50 is going to be at the -1 position, 40 is going to be at the -2 position, until then, till the very first element of your list is reached. Since there are 5 elements, we'll probably going to have the -5 index, -5, then -4, then -3, then -2, and then -1. Okay. So if you want to have the last element printed, you can even use the 5 as an index and also -1 as the index. As I have told you earlier also, that list is mutable. That means once the list is created, you can even modify the elements present inside it. Okay. To modify any element inside a list which is already present, or at the same place you want another element to be added, you can simply write the name of the list. Here we have LST as the name. At whatever index you have to change. Suppose you want to change the very first element of your list, that will be present at the 0th position. Initially we have 10. Now if you want to change it to 100, let's say. Okay. For this, we'll use this LST at the 0 position. We'll assign the value whatever we want to. Then, since with this statement, the list first element will be changed, but to see the change, you obviously have to print the list to get to see that whether it is changed or not. Yeah. So since initially we have 10, now we have 100 at the place. This was about how you can change the value of any elements present inside a list. Now to remove any element present inside a list, what you're going to do, we'll see to it. Removing the element inside a list. Okay. For the for changing any element, you got to know. But to remove an element, we have 3 options here. Either you can use the remove function, you can use the pop function, or you can even use the delete function. Remember, pop and the remove function will delete the single element inside a list, but the del command will completely delete the whole list and will remove the memory allocated to a particular variable, that is list over here. Okay, so I'll use the multi-line comment. I already told you guys that for a multi-line comments in Python, we use the triple quotes. So whatever inside it written is taken as a comment for the compiler. Okay, so for the remove. Okay. Okay. This remove command will remove the first occurrence of an element. First occurrence of an element, by what do you mean by this? First occurrence of an element. Suppose if I say that lst.remove 10, lst.remove 100, that means we don't know how many hundreds are present inside the list, but whenever the compiler will find the first 100, it will only delete that 100. Rest of the 100 will remain unchanged. Cool. Okay, so this was about the remove. Now we'll see the pop function. We'll also do a practical application to it, but I'm just writing here so that you remain familiar with it whenever I go later on the stage. The pop function removes the element at a specified index. Okay, so every function is coming with their own creativity. As you can see, remove function was telling that it will only going to remove the first occurrence of an element, whereas the pop function is saying that It is going to remove a particular element when you specified it with the index. That means for pop, you require an index as an argument. For the remove function, you require the data value as an argument. Specified index or the so also one thing that is coming here is if no okay, I will just write the del also. Cool. So okay, we'll just close this multi-line comments. Yeah. So as I told you, how to change the value inside a list, how to add a value inside a list. For adding the element inside a list, we use the dot append function. Dot append function will, I told you that one remark that comes with the dot append function is that whenever you use the dot append function, that element is going to be added at the very last index. Okay, suppose if there are 5 elements inside your list and you use the dot append function, that element will always be added at the 5th index or at the 6th position. Okay, now when we are looking for how you can remove the element inside a list, we got to know that there are 3 possible ways to delete an element from a list or completely delete a list. We have remove function, we have pop function, and we have a delete statement. That is basically del. For remove function, we got to know that the remove command will remove the first occurrence of an element. No matter how many duplicate values are present inside a list, but only first occurrence of that particular element will be deleted. For the pop function, we got to know that you at least need to have an index. If whatever index you provide inside a pop function, that particular element at that index will be deleted. Also, that remarks come with it. If you provide no index, the last element will be deleted. For the del statement, if you write del lst, that means your complete list will be deleted. Okay. Let's take an overview over this. Now we'll use this function. Now we'll use all these 3 functions one by one. Let's specify a list. I'll keep the list to be very simple right of now. I'll just take the previous one only. Okay. So we have a list name A, which has the value 10, 20, 30, 40, and 50. That means it has 5 elements. Okay. Now we'll write A dot remove. Suppose I want to remove the element 30. Okay. As you want to remove the first occurrence of 30. Okay. Whenever you use any such command that manipulates your list, try to print the list. Because whenever you print the list, you get to know what was the initial value and what is the final touch. It will also help you in checking that whatever statements you have written, are they working or not, meaning are they executing by the compiler or not. Okay, I'll just print A. Here A is the name of our list. Okay, okay, so as you can see that the element 30 is deleted. Now we will see the pop function. For the pop function, we'll write pop. Sorry, a dot pop. Suppose that with the element which is at the first index we want it to be removed. Okay. Let's store this value somewhere. Okay. Okay. Here it is. Popped value is equals to a dot pop. Okay. And I will print this pop value. Let's see, we'll write. Yes. Now we'll print the L A. Okay, so let me define the A here also. Okay, as I already told you that the element at the first index will be removed. So the element that was at the first index is 20, and hence it got removed. Also, it's saying that popped value is 20. That means the element that is removed from the list is 20. Okay. Now we'll use the del keyword. You can use the del keyword, and suppose your name of the list is A. Okay, we'll define the A again here. I'm defining the A again and again so that I will have that fresh list. Also, if there are modifications made, I could able to check whether they are working or not. Cool. We'll now use the del keyword. Del, since the A is the name of our list and we want first element to be removed. Okay. Now I'll print the list again. Okay. Cool. So the element at the very first position that was 10 is now removed. Okay. Cool. Nice. Then now, since I've already told you that how to add an element, how to change the value of a particular element at the given index, how to remove the element with certain conditions, I've told you. Okay. Now we'll see iteration over the list. Iteration over the list. Okay, guys. So for the iteration over the list, I already told you that since we have not covered the loops yesterday, but in today's session, we'll try to cover up the loops. I told you for list, we basically use the for loop. Since we know how many iterations we have to make, or in simple words, I say how many times you have to repeat a particular statement. Am I right? For whenever you don't know the number of iterations that you have to repeat, you always use a while loop, because while is a conditional loop. It will run till the condition is satisfied. Whenever the condition gets out of the whenever the condition is false, the loop will be called off. Okay, so iteration of the list, we basically do this using the for loop. Okay, it is very boring to take the simple list again and again, 10 20. Let's take a character string. Okay, so we have a, we leave the name same. Okay, suppose we have a list of fruits: apple, we have a banana, and let's say we have a cherry. Okay, just to iterate it, we'll use a for loop for item in A. Here A, not just to explain you the for loop in a better way, for is a keyword here. Item refers to the every like pointer that goes over the list. In is again a keyword, and A is a list. Okay, we'll write print item. Okay, since item is now a pointer, you have to use item just to print that. Okay. Okay. Okay, so every element of your list is now printed. This is basically using a for loop. Now let's write another piece of code. We will take over this previous list. Okay, I'll write for I in A, print, okay, I is equal to I plus, okay, I into 2, let's say. Now print I. Okay, till the time it's running, we'll see the code, what it is saying or what it's trying to explain us. See, we have the elements 10, 20, 30, 40, and 50 inside a list. Now we have to iterate, or suppose I have a task to double the numbers which are there inside a list. I suppose I have got a task to double the every number that is present inside the list. When you want to double a number inside a list, what you'll say, you're probably going to multiply the every element by 2. To multiply the every element of 2, you have to go to the every element. To go to the every element, you have to iterate over the list. For the iteration, we use for loop. So here I have used the for loop. I is a pointer that is pointing to every element of a list. Then we have a I, which is I star 2. I star 2 means I is going to be multiplied by 2. Here I, for the very first iteration, we have I 10. It is multiplied by 2 and is stored back in A. It is stored back in A means that the value of I is doubled and is now stored back to A. Sorry. Similarly, this will keep going until all the elements of a list are doubled, and hence after which the loop will be called off. Now we'll go for the sorting in a list. Okay. Okay. We'll see the sorting inside the list. Okay. Sorting is like how, if there are any numeric data present inside a list, or a list contains only numeric type of data, then it is going to probably sort the list for you in the specific order in which you want. Okay. Suppose we have a list A. Okay. Okay. We have a list which has the elements 5, 1, 5, and 6. Okay. If I simply, to sort a list, we use the sort function. I'll simply write a dot sort with no arguments. Okay. Let's see what does this do, and just to see what it has done, we'll print our list again A. Okay. So it has sorted the elements in the ascending order. That means the lowest value element will come at the very first position, and the higher most value element will come at the last index. Okay. Now let's see if we have a second list. Let's say we'll name it as B. We have 5, 2, 9, 1, 5, 6. Since this is a very arbitrary list, I've just taken it randomly. Suppose if we have a sorted list as that's a sorted, we have D. Okay. And I'll just print B. I'll print sorted. Okay. Okay. So the list B was initially 1529156. After it is sorted, we have printed the list again. As you can see, it is sorting the list in only ascending order. That means the lowest value element will come at the first position and the highest most value will come at the last position. Just in case if you want the highest most value element to be at the very first position and the lowest value element to be at the last position, will you, or if you want the sorting to be in descending order, we'll do it with this. Okay. Suppose let's say sorted A. Okay. Let's sorted A, comma, reverse is equals to true. Okay. And I'll just print this sorted. I'll just print this. Okay, so this has printed our elements in the descending order. That means 6 is at the very first position and 1 is at the lowest position. Now we will see the how we can merge two lists. Okay. Okay. Suppose we have a list A as that carries 1, comma 2, comma 3. Okay. Four, comma 5, comma 6. Okay. To merge two lists, we'll simply have C as the other list and we'll just use A plus B function or plus as an operator to merge. We'll simply write print C. Okay. So 1, 2, 3, 4, 5, 6 are now there inside a C. Now, a very important thing to be noted down here is whether the order of occurrence of the list is crucial or is dependent on the operator or not. That means if we write A plus B, does the output is same if we write B plus A? Let's see. If I'll keep the C here, only I'll create a new D as a list and we'll write B plus A. Okay. And I'll just print this D also so that you can see the changes made. Yeah, of course. So as you can see that the order of the occurrence of the list matters. When you have written A plus B, the elements of the list A occurred first. After that, the elements of B have occurred first. But when you have written B plus A, then the elements of B have appeared to be first and followed by the elements of A. Okay. Just a random remark is that if you have any of the numeric data type list and you want the sum of all the elements, you will simply use the sum function. Let's have an overlook to it. If we have 10 comma 20 comma 40 comma 50. Okay. Suppose if we write result as sum A. Okay. Argument, in argument you have to pass the name of the list. Suppose I have A. Okay, shit, I have not written parameter. Result. Okay, so 150 is the summation of all the elements inside a list. Okay. Now we'll go ahead with the how you can reverse a list. Okay, so if we have a list A as mm, we will write A dot reverse. Okay. Okay, I have already told you one thing, that is कि whenever you create a list, you have an original list. But whenever you modify the list, this modification is made in the original list only. Whenever you want the original list to be kept clean, there shouldn't be any changes made. All the modifications should be made somewhere else and that should be kept safe. Then you probably have to copy it somewhere, or even you can try to store the results somewhere else so that your the parent list don't get changed. Here in the reverse function, what we have seen that as you have reversed the number, reverse the list, the elements are changed, and these elements are changed in the original list. For any case you don't want the original list to be appended or changed or modified, you can probably create a new list or copy it where you can store your desired results. Okay. As I've told you that list contains duplicate values. So there are chances that the occurrence of one element is multiple times. It can be even by mistake from the user, it can be anything. But whenever you want the duplicate values to be removed, whatever we do it using a we don't have any function defined for it. We probably use a set, the constructor of a set. Set is also a type of a data type that stores multiple values but has a advantage that you can count, that it does not have any duplicate value. It does not have any duplicate value. That means it will probably, if you provide it with the duplicate value also, it will remove. So now we'll see how you can remove the duplicate values from the list. Okay. Okay. Suppose if we have AL, we'll take the same example we taken it before, 5 comma 1 comma 5 comma 6. Okay. A is equals to list set of A. I'll just print this A so to see whether the results are there or not. Okay. Here this one line statement tells us that here A is the name of our list. This A or this list A is now converted to a set using the set constructor. Now the set constructor has removed all the duplicate value, because since set data type does not support duplicate or repeated values, then this set again is converted to a list using the list constructor, and then we have got the non-repeated list values. Okay. Okay, now let's go ahead. We will see how you can swap two numbers inside this. Okay, so we have a list A which has the values 10, 20, 30, 40, 50. Okay. To change or to swap the two elements, suppose if you want to swap the very first number with the very last number. Okay. And we'll write print A. What we have done here, we have used the multiple assignment. I'll probably have the comment here for this. Okay, so what it has done, the element at the first position is now swapped with the last position. Okay, so this was about the list functions in 1D, in one dimensional. What we saw, what we got to know that the list are mutable. They can be the elements can be changed, deleted, and modified. They can contain duplicate values. They have the zero-based indexing. You can create the list using the list constructor. Then we saw several functions of the list. How you can create a list. How you can create an empty list and you can append the elements inside the list. The append operator always at the element at the very last position. Then we saw how you can like index iterate over the list using indexing and the for loop. Then we saw how you can remove the elements inside the list using the remove pop and del statement. A remove function will only remove the first occurrence of an element. Pop will particularly delete the element that is given to it, like whatever index you give, it will only delete that value. If there is no index, it is probably going to delete the last value. Del statement is also going to delete an element at the specified index. Also, it can be used to delete an entire list. Then we saw the examples over to it. Then we saw how you can iterate over the list using the for loop. Also, we got to know how you can sort a list either in ascending or descending order. For the by default, it the Python compiles it and returns it in the ascending order. For the case of descending, you can simply have a reverse is equal to 2 statement added in the after the arguments just to have the list in the descending order. Then we see how you can combine two lists. To combine two lists, we saw that the order of the occurrence of the list in the operator matters. Then we saw how you can add the every element of a list and have stored in a particular variable. Okay. Then we saw how you can reverse a list. To reverse a list, I told you that you will use that reverse function. Then we saw how you can remove the duplicate values from the list. To duplicate the replicate values from the list, we probably used the set constructor where we first converted our list to a set. The set operator does not support the duplicate value and hence it has removed all the duplicate values from the list. And this one, the parent list of you has now become a set. Now use the list constructor again to convert back it to the list. And the now list that is created is now a fresh list and does not have any duplicate values. Then we saw how we can swap two numbers inside a list. To swap two numbers inside a list, you probably have to use a multiple assignment. Here I have used a list that has values from 10, 20, 30, 40, and 50, where we have swapped the first and the last element of a list using the indexes. Now we will see the multidimensional list or the nested list. I've told you nested means something is inside a something. In case of a list, there is a list inside a list. Then we call it as a nested list. Now suppose if you have a nested list or multidimensional list. Okay. Suppose if you have a list, basically what I was trying to teach you here is that if you want to, if there are students who have something real life application in which you want to use the matrices or any two-dimensional arrays or something, you probably have to use a list inside a list. That means you have to use the nested list. Since you know that matrix is a two-dimensional space, you're probably going to use this nested list. 4, 5, 1, 6. Okay, let's print. Okay, so it has printed our list. To make you more familiar with how you can access a particular element, this yellow braces is the big list, and this pink or the purple list inside it are the children list. So this big list is going to have three values inside it particularly, and each of this child list is going to have three elements inside it. So this one big 1, 2, 3 carrying braces has the index 0. 4, 5, 6 has the index 1. This 7, 8, 9 is going to have index 2. And for each of this 0th index list, 1 is going to be at the 0th position, 2 is going to be at the 1 position, and 3rd is going to be at the 2nd position. Suppose if you want to access matrix, if you want to access, let's say if you want to access very first element, we'll simply write 0 followed by another braces 0. Okay. Okay. So this our one is printed. Similarly, if you want to print the second element, we'll write this 1 and we'll write here 2. Okay. 1, 2, 3 and print it. But if you want to print this 4, 5 and 6, I've told you for 4, 5 and 6, the parent value of the yellow braces is 1. And for each of them, we'll have another place of indexing. That means 4 is going to be at the first 0th position, 5 is going to be at the first position, and 6 is going to be at the second position. Similarly, we'll just have to change 0 to 1 here. Cool. Hmm. 5 is going to be at the 1, 1 position, and 6 is going to be a 1, 2 position. Let's print this. It's 1, 2, 3, 4, 5, 6. Surely correct. Now we'll have the similar one for the third element as well. Third element will be going to be at the 7, 8, 9 has the parent index at 2. So we'll just change 0 to 2 here. And the other indices will remain the same. That is, 7 is going to be at the 0th position, 8 is going to be at the first position, and 9 is going to be at the second position. I'll just add some of the space here just to see that things are properly visible to you. Okay, cool. Okay, so this is going to have 2 12. Okay, so the first element has 1, 2, and 3. Also, 1 is at the index 0. Similarly, we have printed the other values also. This is how you can iterate using indexing inside a nested list or a multidimensional list. Now we'll see some of the methods on multidimensional arrays. Okay. Like very first one, we have how you can add an element inside a multidimensional array. In case of a list, we use the append function. Similarly, we are going to use the append function here also. Okay. We have already A defined here. Suppose we write it again here. Okay. If I write A dot append, let's write 7, 8, 9 is done, so we'll write 10, comma 11, comma 12. Okay. And we'll print this again. Okay. Okay. So 10, 11, and 12 are basically added at the last position after 7, 8, and 9. Okay. Now we'll also see an extend function here. What does the extend function do? We know that at the 0th position we have 1, comma 2, comma 3 as the elements inside a list. I want to extend it. I want to add few more elements inside it. So I'll write A braces 0, that means at the 0th position, dot extend. Okay, we will have we have a round braces here, and I'll write 13, comma 14, and comma 15. Dot a point. Okay, cool. And I'll just print this A again to see whether my results are changed or not, or my list is changed or not. Okay, so you can see that at the 0th position, the elements are now extended, and 13, 14, 15 are also added. Cool. Now we will see how you can reverse a multidimensional array. Suppose I'll write A dot reverse B dot reverse, suppose, and I'll just print this. Okay, so the elements are reversed. Similarly, if we want the elements inside in the first element or the very last position to be changed or reversed, we'll write A. For the very last position, we use the index -1. Then I'll write dot reverse. Okay. I'll write this print a. Cool. Okay. As you can see that only the elements of a last element of a parent is changed. That means it was initially 1, 2, 3, 13, 14, and 15. Now it is reversed in this order. 15, 14, 13, 3, 2, and 1 are changed. So it is changed as a very internal structure only. The whole of the list is not reversed. So this was about the multidimensional arrays, how you can iterate, how you can use the indexing to get a particular value. Then we saw how you can append an element inside a multidimensional array. Then how you can extend an elements that are already there inside a list. I told you how you can reverse a whole list, or you can reverse a part of it. Let's go back to the presentation. Okay, so this is all almost we have done. Len mylist function is basically used to return the total number of elements. Mylist.append is going to append the red inside mylist at the very last position. Dot extend function is basically going to extend the elements, or these elements are going to be added there. Mylist.count function. Okay, so this count function we haven't done, but this dot count function is going to see or return you the number of times 3 has occurred. Okay. Mylist.pop will pop the very first number, that is 0 is the index here. Mylist.remove the item from the list. Mylist.reverse is going to reverse the list. Similarly, dot clear function is going to clear the list. That means all the elements that will be inside the list will be deleted. Then del mylist. Okay, so this is little tricky, or we haven't done till yet. Is that del function is basically used to delete it. Mylist here is the name of a list. Start and an increment. That means from here to here, please delete the elements inside the list. With an increment, that means the index will is going to change by this much increment. Del mylist is going to completely delete your list. Dot insert function is going to insert the hello at the very first at the index 1. Mylist dot sort is going to sort the list, but particularly by default in the ascending order. If you want it in the ascending order, you need to have a reverse is equal to true. Mylist dot sort keys equals to length will basically going to sort your list with length as a function. For the length of a function, that means if you have multidimensional array, it is going to sort the number of elements that are there inside a child list. Okay, so this was all about the list we have done. Let's move back to the loops. You have already seen the little working of for loop. Okay, now today, in the next, let's for next few minutes, we'll see loops. From the word loop, we basically means to execute it repeatedly, right? Here, loops are used to execute a block of code repeatedly. Whenever you want a particular task to be executed n number of times or any number of times, you use a loop. Python provides two types of loops. It can be either a while loop or a for loop. For loop we use when we know the number of iterations we have to make. A while loop we use when we don't know the number of iterations we have to make, but we know that for certain condition we have to do this task. If this condition is not satisfied anywhere, we have to call off the loop. So the one basic advantage that comes with the loop is that the loop reduces the code repetition. That means you do not have to write a piece of code n number of times or any number of times, and this way it makes your programs more efficient and readable. Okay, so let's see for loops in Python first. As I've told you, for loop you need to have one thing very necessarily kept in your mind, that how many iterations you have to make. What is the basic use of for loop? We have studied list before this. We saw how you can iterate in a list using the for loop. So A for loop can be used to iterate over a sequence that could be either list, tuple, string, a dictionary, or anything. Okay. For a syntax, we have for as a keyword here. For item is a like a pointer that will be pointing every time the loop is executed inside a code. In sequence, sequence is probably going to be anything. It could be a list, it could be a name of the tuple or anything. Then we have several statements inside it or whatever task you want it to be proceeded ahead. For example, if you have for num in list 1, 2, and 3, so num is a pointer here that is going to point every time the loop is executed. 1, 2, and 3 is a list. So for and then this print num is going to print the each and every element of a list. Here num, when will the first iteration of the loop will occur, num will have the value 1 and hence 1 will be printed. Second time when the loop will be occurred, like iterated, it is going to have 2 value. And this third time loop will be executed, it is going to have the value 3 and hence 1, 2 and 3 will be printed. Similarly, if you want to have while loop, for while loop we already know that we don't know the number of iterations. We just have a condition. Until that condition is satisfied, the loop will be executed. As soon as the condition is not satisfied, the loop will be called off. For the syntax of while loop, we have while, we have a condition here. Remember, this condition should always have a result in the Boolean value. That means it can either have a result as true or false. That is 0 or 1. Then we have a piece of statements defined inside it, whatever you want to execute it. Let's take an example. Here count is a variable that has initial value of 1. Now while loop is saying that whenever till your count value is less than or equal to 3, please print the count. For the very first iteration, we have the count value 1. The condition is satisfied because 1 is less than 3. Okay, so 1 will be printed. Also, as you can, I don't know how much like you people will be able to identify, but this in this way the count value is not changing. When this value of count is not changing, this while loop will continue. Continue means that this will become an infinite loop, and your system will be like continue to display the value of 1111. To make this loop like terminated, you probably have to modify the value of count so that the condition is so that the point is reached where the condition is not satisfied. Because continuously learning the loop infinite number of time is not efficient for the system also. Now we will see various loop control statement. Loop control statement means this statements that will control the execution of the loops. We have three loop control statements: break, pass, and continue. Break will exit the loop like at the point whenever this break will be called. Continue, this will skip the current iteration. That means whenever whichever iteration is going on, that will be just like will be skipped and the next iteration will be made. Similarly, for the pass, it is not, it like basically does not anything. It is just going to like used as a placeholder, or you can say it's just going to skip that particular statement. Example, suppose for here we have used a for loop. Suppose if you have a for num in range 5, in range 5 function is going to give you a array or a list of numbers that will have the value from 0, 1, 2, 3, 4. Okay, 5 will not be included. The range function will always have the value from 0 to 5 minus 1 or 0 to n minus 1. It is saying that if num is equal to 3, break and print that num. Okay, so we have 0, 1, 2, 3, 4 as the elements inside it. Num will have the first value as 0. This condition is satisfied, hence this is break. Similarly, we have the nested loops. Nested, I've told you, nested means something is inside of something. So for a nested loop, we have loop inside a loop. We have also seen about the nested conditional statements. We also see how you can have a multi-dimensional nested list. Now we come on to the nested loops. A loop inside another loop is basically a nested loop. For example, if you have for I in range 3 and for j in range 2, that means I will run three times and j will run two times. For each of the iteration of I, j will run 2 times. So for 3 values of I, we will have 2 values, for each value of I, we have 2 values of j. So for 3 values of I, we will have 6 values. Means this will execute properly 6 times. Here we have loop with else clause. How you can use an else clause or an else statement inside a loop? Okay, so for example, if you have a list with range 3, that means it is going to have zero values 0, 1, 2, and okay, 0, 1, and 2 only. It is probably going to print every number. The else clause, what will do, it will just print whenever this loop will finish all of its iterations, it will simply print that loop is completed. Okay, so this was the basic understanding of the loops. Now let us come to the practicals part. Okay. Okay, we will see Python loops in Python. Okay, let's write the basic syntax of it. Okay, we'll just have while. While is a keyword here, remember. If we have, and we have an expression that has the boolean value. Okay, and then we're probably going to have the statements here. Okay, so this was about the syntax of the while loop. Okay, so for a very first sample of this while loop, let's see, we have a count variable and it has the initial value of 0. And I'll write while count is less than 3. Okay, let's increase the count value to. I've already told you that try to bring a while loop to a situation where it ends. If there is a situation where, if there is no situation where the while loop is ending or is terminating, you're probably going to fall into the infinite loop, which is not good for the system. Okay, let's see, print something. Print hello world. Okay, okay, so what it has done, that for the first time the count value was 0, so this loop is executed. The count value is now increased to 1 and the hello world is printed. Now the count value has 1. 1 is still less than 3. This loop will be executed and the hello world will be printed. Now this loop has got the value 2. This 2 is still less than 3. This count value will be increased to 3 and this hello world will be printed. For the third time, for the fourth time, what will this happen? That 3 is not greater than 3. That means this is the first statement and this loop will now be executed. Okay. Now we'll see the while loop with the else clause. Hmm. Now we'll see while loop with the else clause. We'll see the basic. We'll see the basic syntax for this. Okay. For the while loop, we have told you we have a while keyword, then we have an expression there. Okay. We have a while, we have an expression there, then we have statements. Then we have the else clause, else have no. We will have statements here. Okay. So this was the basic syntax where we have a while expression. We have a while where we have a statements. Then we have a else clause. Else clause, remember, else clause is after the, like, it's outside the loop, it is not inside the loop. Okay. Okay. Now we'll see example to it. Okay. Okay, so we'll just use see the same example of this count. Count value as 0. Count and we'll write well, count is less than 3. Okay. So here what we have done, we have a count variable which has the value 0. This loop, while loop will be executed till count value is less than 3. Each time this while loop is executed, the value of a count variable is increased by 1 and hello world will be printed. As till this while loop, like till the time this while loop will be executed, the else block will not be executed. This else block will only be executed when the while loop will be called off. Okay. Okay. Let's run this. Okay. So this hello world is printed 3 times, and after it, when the count value of 3 becomes 3 and 3 greater than 3 less than 3 becomes the false statement, the loop will be called off and it will execution will enter into the else block, and the inside and else block will print statement will be printed. Okay. Just to like give you an example over the infinite loop. So here we have a count value of 1 and we'll write the condition as while count is equal to 1, print high. Let's see. I'm not going to run this loop, but I'm just going to give you a basic understanding of this piece of code is, since you have kept a value of count to be 1, and this count value, this while loop also has the condition of that if the value of count is 1, print high. The value of count is not changing, it is remain 1, and this condition for the while loop will always be true, and hence this high will be like printed multiple times. This loop will enter, this piece of code will enter into a infinite loop, and hence it is suggested not to use this type of loop, as it is never ending infinite loop where the condition is always true and you have to forcefully terminate the compiler. Okay, so this was about the while loop. Let me recall the while loop again. While loop has the syntax. While loop is basically used when you have a condition to execute a particular task number of times. Also, we saw what is the syntax for while loop. Then we saw an example. We saw how you can use an else clause with the while loop. Then we saw how you can stop your compiler from entering an infinite loop by actually keeping a condition where your while loop condition is not satisfied, so that your loop is called off. Okay, so let's come on to the for loop. So for the for loop, I've already told you to like have a for loop. You already need to have the number of iterations that you have to make. Okay. Okay, let's start with the writing with the syntax. Okay, we'll add the keyword for. For we are going to have a iterable variable here. Okay, we'll have some statements here then. Also, one thing I'll write here is that for loop can be used to iterate over a range of values and sequences. Okay. Let's see an example to it. Okay. Suppose if you have n as a 4 here, you have just a variable randomly, and we'll write for I in suppose we write for I in range 5. Okay. Print I. Okay, I'll write a comment here just to make you more familiar with the range function. The range 5 is equal to 0, comma 1, comma 2, comma 3, comma 4. Okay. Similarly, if you have a range 0, comma 1, comma 2, comma 3. Okay. This is what the range 5 or range 4 or any number will tell you what all values of range this number will give. Okay, this is particularly printed. Okay, now we'll see an example of how you can iterate it over a list. We have already seen it, but we'll see in some new way. Suppose we have a list is equal to hello, comma, Python, learn. Okay, suppose we have this list. Now we write a for loop to iterate it. For index is iterable variable here. In range, length, lst. Okay, we'll print lst index. Let's run this. Okay, so this is what this is doing. Index is an iterable variable here for range length list. Length lst is going to return you the count of the number of elements present inside a list. For the list lst, we have 3 elements. So this is probably going to give you a number 0, 1, and 2. So index is going to have value 0, 1, and 2. LST index will return you the value of an element at that index. So this will print the element at the index 0, 1, and 2. Okay. Now we'll see how you can use else statement with for loop. Else clause with the for loop. Okay, we'll see the syntax to this. I think we have already this, like in case of while loop we have seen it's going to be similar. There's nothing going to change. Just in case of while we have the for loop, and the position for the else clause will remain the same. So let's jump on to the example. Suppose we have a list here. Okay, you'll have a list name. Let's say list here. We'll take the same piece of code and we'll just have a special else clause after this. Hello Python. Okay. For index in range, length function is going to return you the total length of the list. Lst. Print lst index. Now we'll have the else block. Let's simply write print inside an else block. Okay, let's run this. Okay, so what it has done is first executed the for loop. As soon as the working of the for loop is stopped, it has entered into a else block. Okay, now we will see the working of the nested loops. Okay, now we'll see the syntax for the while nested while loop and the nested for loops. Okay, let's write the. Okay, first we'll see the while loop. We have while, then we have an expression. Okay, then we have an again while, we have an expression, then we have statements, and okay, so this was about the while loop. We'll see for the for loop now. For iterable variable sequence. We again have the while loop for iterable boolean sequence. We will have statements. Then probably we're going to have this. Okay. So this was the syntax for the nested while loop, and this was the syntax for the nested for loop. You can add as many as loops inside a loop. This is not any. There's no such mandatory condition for adding the number of loops, but you can add as many as you want. Now see a simple example over to this using the for loop. Suppose we have for I in range, let's say 1 to 5. Okay, then we'll have, suppose for j, another loop for j in I. Okay, okay, we'll just print this j, and end is equal to, okay, this end is equal to 0 will will point the pointer into the next line. That means when this second loop will be executed, this print statement will come into the next line. Okay, okay, let's understand this what it has done. For the very first I, it is going to run, and this j is going to run the number of times the range function will have the I value. Okay, this end is going to always point the pointer to the next line. This print statement is going to leave a space. Similarly, now we'll see the loop control statement. Okay, I've already told you the loop control statements change the executions from the normal sequence. When execution leaves the scope, all automatic objects that were created in that scope are destroyed. Python supports the following control statements, that are continuous statement, break statement, and pass statements. First, we'll see the control statement. Continuous statement. Okay. So the continuous statement in Python returns the control to the beginning of the loop. To the beginning of the loop, that means it is going to skip the current iteration. Okay, let's write this. The continuous statement in Python returns the control to the beginning of the loop. The loop. Let's have an example to it. Suppose if you have for loop for letter in, let's say Python. Okay, so Python is a string here and it is going to iterate to over it. Okay, so we're going to have a condition if letter is equal to E, or letter is equal to O. Continue. Okay, and we'll just print the current letter that was there in which for which the pointer was pointing it. Okay, let's run this. Okay, for what it has done for each letter, it will point to a particular letter. For P, the condition is first false. For Y, the condition was false. Similarly, for T and H, it was false. But when it has come to O, the condition was true. But since it has the continue statement, that means this this continue is going to bring the loop back to the starting. Like the for loop will again be executed for the next iteration, and for the next iteration we have the letter value as n, which is again going to bring the if condition to false, and hence this print won't be printed. Okay, let's see the break statement now. Okay, we'll see the break statement now. The break statement in Python brings the control out of the loop. That means the loop will not be executed, and this will be terminated. Let's write this also. Will okay. Let's see example to it. Suppose if I write for letter in Python. Okay, similar example I will take only so that you get a better understanding of each the statement, that is the each control loop control statement. Okay. If letter is equal to E, or letter is equal to O, break. Break, and now I'm going to add this print statement not inside the loop. Print Okay. So similarly for the case of continuous statement, what it has done, it has gone for the next iteration. For the next iteration, we have n. Since n is not satisfying our if condition, and hence this print statement was not executed. But in case of a break statement, what we got to know is that as soon as the if condition is satisfied, the break statement was called. Break statement has brought the execution out of the loop, and hence the print current letter that was O is now printed. Similarly, we'll see for the go with the pass statement also, and then after which our loop control statements will be finished. Okay, pass statement. Okay, we'll see. Okay, we use pass statements in Python to write empty loops basically. Pass is also used for empty control statements, functions, and classes. Let's write this piece of thing also here. We use pass statement to empty the control statements. Okay. Now we'll see an example to this. Suppose if I take the similar example and I use the pass. If letter is equal to E. I'm just taking the same example just to make sure that how the similar just a piece of word or a word can like change the whole execution of the program and can even bring the new output. Okay. So this pass, after this pass, I will basically add the print statements after the loop. Okay, print the current letter. Okay. Okay, so let's see the working of this. For each letter for P, this if statement will be false. This pass will not be executed. For Y also, for T also, for H also, and for O also, this will be true. But since there is a pass, it will go for the another iteration. For the another iteration, we have n. This condition is not satisfied, and this loop will be ended. After this loop, we have a current letter. The current letter is n, and it should be printed. That means if you use the pass here, the letter, very last letter will be printed. So this was about the loop control statements. I already told you there are 3 loop control statements. Continue, pass, and break. Continue is basically going to just skip the current iteration and like have the next iteration. Break statement is going to bring you out of the loop. Pass statement is going to like do nothing. It is just going to pass the things and the next iteration will be taken over. So this was about the loops. Let us revise all that we have learned in loops again, and then we'll go to the tuple sections. So for the loops, we have loops are particularly used to execute a block of code repeatedly. For Python, we have 2 loops, for loop and while loop. In other language, we have do while loop also, we have for loop also, and we have while loop also. Do while loop in other languages basically used to at least run a while loop one time. That means if your while in this scenario, if the while condition is not satisfied in the first time, no loop will be executed, and there will be no use of loop basically, because any number of times that loop will not be executed. In a do while loop, we basically use it to at least run our while loop for at least once. As you know that loops will reduce the code repetition and will make it more efficient and readable. Then we saw what is a for loop, how you can use it in iteration over a sequence such as list, tuple, and strings. Then we saw while loop, which is a conditional loop in which you need to have a condition. Whenever this condition is not satisfied, the loop will be called off. Then we saw the loop control statements. We saw how you can use the break, continue, and pass statements to actually give more efficient working to your loops. Then we saw the nested loops, which are basically a loop inside a loop is known as a nested loop. This Then we saw loop with the else clause, how you can use the else statement with the loop. Now we will come to the tuples. Since you have already know the list, tuples is also a type of a data type, is also a data type in which you can store multiple values. Remember, list was mutable data type, but tuples are immutable data type. That means once the tuple is created, you cannot modify it. The elements will remain same. They can store elements of different data types. Similarly, like the list, you can use as many as data types you want to store in a particular tuple. Tuples are ordered and allow duplicate value. That means they are ordered and they can take up duplicate value, whereas the set does not take up the duplicate values, right? Okay. Tuples are basically stores the value inside a round braces. Tuples elements can be accessed using indexing. I told you in Python we have zero based indexing, so it can be the tuple elements can be indexed. Then we have to see how you can create a tuple. See, to create a tuple, we will simply use the parenthesis round braces. Here we have a tuple name as my tuple, and we have round braces in which inside we have 1, 2, and 3 as the value. Suppose without parentheses, if you have the values 1 comma 2 comma 3, then you can like also have it. We can have also a single element inside a tuple. Okay. Also, you can use a tuple constructor to construct a tuple. Since one here you can see it that 1, 2, and 3 have are stored inside a list. This now list will be converted to a tuple using a tuple constructor. Okay. Now we'll see how you can access the tuple elements. To access the elements of a tuple, we can use indexing. This my tuple is the name of a tuple. 0 is the returns. So this basically returns the first element of a tuple. You can. It also supports negative indexing. That means my tuple -1 will return the last element. Now there is a new word coming, slicing. Slicing in tuple basically use if it is written 1 is to 3. That means from first element from the element which is at the index 1 to the element which has index 2. This 3 will not be included. Remember, 3 is always excluded. Then we have the tuple operations, tuples method, and tuple packing and unpacking. Okay, we'll see it one by one. For tuple operations, concatenation. Suppose if you have two tuple 1 and tuple 2, if you want to add both of them, then you simply use to have a plus operator. Suppose if you want to repeat a particular tuple n number of times, that means this tuple star n will do it. Membership, that means item in tuple. Suppose if you have an iterable variable item, n is a keyword here in tuples. This will basically return into a true or a false value. That means it will return true if the element is there inside a tuple and will return false if the element is not there inside a tuple. Length, how you can determine the number of elements there are inside a tuple using the length function. Okay. Then we have a tuple methods. I will just have a practical applications also once we'll just have a overview over the slides. This count function will basically count the occurrence of an element. The index function will return the index of a particular element. Min and maximum will find the smallest and the largest elements that are present inside the tuple. And the tuple is going to convert this. Basically, this is a tuple constructor, and basically it converts an iterable to a tuple. Suppose if you have a tuple, suppose my tuple is equals to 1, 2, and 3. This is going to give you a tuple. A, B, and C is equals to my tuple. This is basically going to unpack your tuple. Okay, you can use star to capture multiple values inside a tuple. We'll see this in the practical application here. Wait. Okay, let's start with the tuples practical application. Suppose if you have a tuple T, you know that it is going to be enclosed inside a round braces. And we'll just print this T. Okay, so it has printed our tuple. Let's see what is the type of a tuple. Print of type T. Okay, it should belong to a class of tuple. Let's see. Okay, so it belongs to a class of tuple. Okay, so as I've already told you, unlike the Python list, tuples are immutable. Some of the characteristics of the tuples in Python are that tuples are ordered and we can access their elements using their index. You cannot update items to a tuple once the tuple is created. Tuples cannot be appended or extended, meaning you cannot add the elements or you can change the size of a tuple. Also, you cannot remove the element of a tuple. So let's just revise it once more. That is, the tuples are ordered and you can access the elements using indexing. But one thing that is there is you cannot modify the elements of a list. You cannot add elements inside a list. You cannot delete elements inside a list. But you can have a duplicate values inside a tuple. Okay, let's see how you can access the elements inside a tuple. Suppose if you are tuple T, 10, comma 5, comma 20. Okay, we'll just use the normal indexing only. Say tuple 0. Okay, this is going to print the first element. Then similarly, if you want to have this second element to be printed, we'll write print T1. Print, let's see if you want to print the third element T. Okay, we'll write 2. Okay. Okay, so we have a tuple with the values 10, 5, and 20. 10 is at the index 0, 5 is at the index 1, and 20 is at the index 2. And similarly, we can print access them using their indexes. Cool. As I've told you, tuple also support the negative indexing. Let's see what happens if you have the negative index there. Print T minus 2. Print T minus 3. Okay. Okay. Let's print that. Okay, so 20. This shows that tuple supports the negative indexing. Okay, so let's iterate it. Let's iterate over a tuple. So for that iteration, we'll use a for I in T. Let's change the tuple. We'll have new tuple here. Huh? Comma 2, comma 3, comma 4, comma 5. Okay. For I in tuple T. Print I. Okay. Print I. Else and is equal to 0, so that we have every element in the new line. Okay, I'll just remove this. Okay, it's okay. So we have the every element now. Now we'll see how you can concatenate inside a Python tuple. Suppose if you have a tuple t1, it is equal to 1 comma 2 comma 3 comma 4 comma 5. Okay. Now we have a tuple 2. Let's say t2 is equal to 6 comma 7 comma 8 comma 9 comma 10. Okay. Now we just have to have print t1 plus t2. Okay. The concatenation basically means that 1, 2, 3, 4 followed by 6, 7, 8, 9, 10. Now we'll just have a look over the order also. If we have t1 to t2 plus t1, in case of a list, the t2 elements should appear first. Similarly, we'll see that for the tuple, do we have this case or not? Okay. Our assumption here is that the T2 element should appear first. So, okay, for in the order matters here, and the T2 elements will appear first if you have written T2 plus T1 followed by the T1 characters. Okay. Now we will see how you can create the nested tuple. That means tuples inside a tuple. Suppose if you have a tuple T1 is equal to 1 comma 2 comma 3 comma 4 comma 5. Okay. Now we'll have a tuple T2. Let's say suppose we have a Python comma learn. Okay. And let's see we have a tuple t3. Let's say we have it as t1 comma t2, t1 comma t2, and I'll just print this. We'll also check for the order here even, but let's see the first case. Okay, so new tuple is created in which 1 2 3 4 5, that means tuple 1 and tuple 2 are the individual elements present inside it. Now we'll just change the order here for a new tuple, that is t4 is equal to, we'll have t3, we'll have t2 comma t1. So for this case, our T2 element should appear first. That means Python and learn should be the first element. And okay, I should to print this also. Okay. Python and learn should be the first element, whereas the 1, 2, 3, 4, 5, that is the T1 element should appear next. And this is only happening here. Okay. Now you can see how you can repeat a particular tuple. Let's see, we have a tuple T is equal to Python. Okay. Now we have, remember for a single element you should always have a comma, okay, separated, otherwise it's going to give an error. Okay. Now we have just have to print T star, let's say 3. Okay. Okay. So for this case, the Python, which was the first element, is now repeated to 3 times. This is how you can repeat an element inside a tuple. Now we will see how you can do slicing. Slicing means to select a particular subtuples inside a tuple. Suppose if you have a tuple T, okay, so if you have a tuple T which has the element 0, 1, 2, 3, 4, and 5, that means it has 6 elements in total. And if I write print T1 is to 4, that means from the first index to the third index it should print the values. That's long. Okay, so first index we have 0, 1, at second index we have 2, at the third index we have 3, and these are only printed. Okay, now we'll see how you can reverse a tuple using this slicing. Let's say T. Okay, so what it has done, it has started with the 0 and the -1 index is now not there. Now similarly, we'll see how you can reverse a list. Okay, reverse a tuple, sorry. Okay, so in this way you can reverse a tuple using double is 2 and then -1. So you can even use the reverse function, but this is also a way of how you can reverse a tuple using slicing method. Now we'll see how you can delete a tuple. Okay, let's say if we have a tuple t is equal to 0, 1 and just say using del keyword if I delete t and just I'll see print. I'll use the print to see whether it's still existing or not. Okay. Okay, so it is saying that name t is not defined. That means the del t word has been del t statement has worked and the t is now deleted. Okay. Let's now go ahead with other things. Now we'll see how you can find the length of a tuple. Suppose if you have a tuple t and we have the elements such as 0, 1, 2, 3, 4, 5. Okay. And I'll just print len t. So this length t statement will give me the total elements present inside a tuple. As I've already told you that tuples support the multiple data type values inside a single tuple and hence it is heterogeneous in nature. Now let's see how you can convert a list to a tuple. Okay, so this conversion we can mainly see tomorrow since the time is also up. Okay, now we'll just have a quick revision of what we have studied inside a tuple. Let's come back to the presentation. Okay. Since tuples in Python are data types that support multiple values of different data types, they are immutable. That means once they are created, the values cannot be changed, appended, or can be removed or erased. If you want to delete anything inside a tuple, an entire tuple is deleted. Remember, a single element is not allowed to be deleted. A tuples can have duplicate values. Tuples values are stored inside round braces and can be accessed using the indexing. Then you can create a tuple using various methods. The one that works well is the using the parenthesis, but also you can use a tuple constructor to create a tuple. Basically, tuple constructor is used to convert a list to a tuple, a string to a tuple, or a set to a tuple. Okay. Then how you can access the tuple elements? To access tuple elements, we basically use the indexing. Since in Python we use zero-based indexing, so first element will be at the 0th position, followed by the increment, and at the last position we'll probably going to have the n-1 index, where the n is the total number of elements present inside a tuple. Also, it follows the negative indexing. That means the last element is going to have the -1 index. Tuple supports slicing. That means you can select a subset out of a tuple. Then we have the operations on tuple. You can particularly combine two tuples using a plus operator. You can repeat a particular tuple using the star operator or asterisk operator. You can see the membership of a particular element inside the tuple using the in operator. You can find the length of a tuple using the length function, in which you have to provide the name of the tuple as an argument. Then we have the several tuple methods such as count. This basically count the occurrence of a particular element inside a tuple. This index will going to return the index of an element. Min and max function is basically going to give you the smallest and the largest value that is present inside a tuple, which has the numeric values. And this tuple is basically a tuple constructor, which is used to convert a string to a tuple, anything like of list to a tuple, such ways. Then we saw how you can pack and unpack inside a tuple. Also, you can use the star to capture the multiple values. Let's see what we have done here. Okay. We saw how you can create a simple tuple, how you can print it, how you identify that it belongs to a class of integer using the type function. Then you saw how you can access each element using indexing, both with the forward and the backward indexing, that is with the 0th and the negative indexing. Then you see how you can use the for loop to iterate inside a tuple. Then you saw how you can perform the concatenation of two tuples, that and in which you also saw that the order matters. That means if you write, if there are two tuples t1 and t2, and if you write t1 plus t2, that means the elements of the t1 will be taken first, followed by the elements of t2. But if you change the order, that means if you bring the t2 plus t1 argument there, then t2 elements will be added first and followed by the t1 elements. Then we saw how you can create a tuple inside a tuple using this. Then how you saw you can repeat a particular uh, tuple n number of times. Here I have repeated it three times. Then we saw slicing. In this slicing, we saw that if it is written 1:4, that means from the index 1 to the index 3. That means 4 will not be included here. Then we saw how you can reverse a tuple using the slicing. Also, how you can delete a complete tuple using the del keyword. Then we saw how you can find the length of a tuple using the length function. So this was all about the today's session. In today's session, we continued with the list functions. We saw more over the list. Then we got to know about the loops, for loop and while loop with the else clauses. We saw the nested loops. Then we came to the tuples, where we learn about the tuples, nested tuples, how you can delete a tuple, how you can repeat a tuple, how you can uh, like find the length of a tuple. There are various functions, how to pack and unpack inside a tuple, how to reverse a tuple. So this was all about today. See you tomorrow in the next session. Most probably we'll start with the strings and some user defined functions, that how you can create a function. Okay, so I guess everybody is okay. If you have any issues, you can particularly write me at my mail. I'll write here. For any queries, you can mail me here. Okay. Thank you guys. Have a good day ahead.